So okay, we're going to be looking at two tools today. We're going to be looking at Volatility, which is basically a tool that is used for forensics, security forensics rather. So what this tool does, it does analysis on memory images. For example, we have a Windows machine that has been hacked, and we managed to get a dump from the memory at the point at which the machine or the computer was last active. So using Volatility, we can pretty much go over what was done on the machine, the commands, the passwords, etc. So not only does it get used for forensic things, it can also be used as a hacking tool. So if, for example, you're a hacker and you're working on a pen test or what sort, you can pretty much dump the RAM, which is the memory in real time, and then you could go over it. So there are quite some interesting things in RAM. There is LSAS, which holds the passwords for the clear text passwords for the authenticator users and users that have sessions that are active on the machine. You could also dump the hashes and attempt to crack them. So, for instance, you want to get an administrator user's password, but then the administrator user doesn't have a valid session or an active session at the time where you freeze the machine and export the VMM. You can pretty much go over and dump all the hashes that are exist in the same file, which is pretty much the file that holds all password hashes for KBRS authentication or just basic authentication. You can dump the NTLM hashes from there and to crack them offline or online with tools like CrackStation or offline tools like Hydra and John the Ripper and Ashkid, etc. So what we're going to do first, you need a profile. So when we say profile, we mean that we need a profile of the actual operating system bus on the machine. So using our tool here, we can pretty much get that for ourselves. So what we need to do is, for instance, here, if you do ls, we can see that we have the vmm here, and then the volatility tool is in over there, but we have moved it to the path so we can call it from everywhere. So we're going to do sudo and then volatility and then dash f. So dash f means we're going to be pointing to a file which is the vmm that we've extracted, and what we want is the image info so that we can start using the profile to make more queries over to the vmm. So we're just going to put the password here, and this will take quite a while, so we will wait a few seconds, and then once that's done, we will have our info here. Then we can take the profile info and then we can use it for making more queries. For example, like I mentioned earlier, to dump the VMM's LSAS, to dump the VMM's same hive. It's to look at the running processes while it's the machine was still on and things like that. So we will wait for that. Okay, so there we have it. As you can see, we have our profile here. So what we mean by profile is all of these profiles for Windows 7 server specs, but then here you find that it arranges them with the possibility of likeliness. So here we have the Win SP1 S64, which has been put first, and then effectively preempting all the other profiles, which means that probably our VMM was extracted from a Windows 7 SafeSpec 1 x64. Now we are going to be using this quite a lot because we want to specify the actual specification of the suggested profile so that we don't get any errors when we're getting our information. So before we get into that, we are going to be looking at a bunch of things that we can do. Just a small overview for what volatility is able to do. Sorry, my typing mistake there. So if we say volatility dash h, yeah, this will just pull up all the possible commands that you can run. In addition to that, it will also pull out all the various commands and templates that we can run. For example, here they previously we said image info, so that's a commandlet for getting information about the service spec versions or possibly of the computer that we are going to be looking into. So if you scroll up here, dash h is for help as we've used it. So what it does, it lists all available options, like I was saying, in their default values, etc. This is all the other information that you use. So the only information that makes sense right now is the dash F, specify the file name, which in our case is the file name of the image that we're going to be working on. We could use write if you want to enable write support, but for this instance only, we're going to be using the dash F to specify the file name. Now, if we go a bit down here, you see here where it says supported plugin commands. So it is a bunch of supported plugin commands like amcache, which prints the amcache information. Let me just see if the one we just used now, yeah, here it is. So as you can see here, we have image info, which identifies the information for the image, which we will then use at a later stage to pretty much just make sure that we are making right queries. And also, before I forgot, there is also one more command that we'll be using, which is the dash dash profile command. I don't see it listed here, but it's still fine. I'll explain once we start. Okay, there it is. So this dash dash profile command is where we will add the profile that we got from our previous result, so that our volatility knows exactly how to make specific queries towards that specific profile, so that we don't have any issues. As you know, Windows devices, they define profiles. We have XPS, Service Pack 2, we have spec ones for Windows 7 and so forth. So right now, let's just clear the screen. So right now, what we want to do is, since now we have our profile, which is WinSP1x64, we want to do a hash dump. So what a hash dump is basically um, uh, pretty much dumping all the hashes that are in the same hive. So hashes are almost equivalent to passwords, with just the misgiving that you have to crack them. So here we're going to say sudo, and then volatility. So we're going to say sudo a lot because we are not running in the context of the super user here. Then dash f, where we will specify our author ctf.vmem file, and then we're going to do a dash dash profile. So for this dash dash profile, like I mentioned before, this is where we're going to be adding our uh, profile that we got from our initial command let to get the info. So let me just copy it from somewhere, since it's just quite tricky to type. And then we're going to say hash dump. So this hash dump command let just basically lets you dump all the hashes from the same hive, as they are stored in the same hive. So now if we say enter, I hope it won't take a lot this time as well, but pretty much probably will, because the vmem file is a bit long, it's a bit big, and it definitely has to just make some queries from it. And also another issue is that the reason why it's so slow is because the vmem image is quite unstructured, which means all the data is just scrambled there. So the reason why we use the profile here is so that volatility knows exactly when it's working with a Windows 7 SP1x64. It knows definitely that the data is unstructured, but it has a way to sort of structure the data. So as you can see here, we have the administrator uh, seen by the ID UID 500, and this is the password hash, which is NTLM hash. So we can attempt to go to crackstation.net and see if we can crack the hash or any of these hashes for that case. So let's just try it now. Crackstation.net. So we should be able to crack these hashes pretty easily, given that this was a VMM used for a CTF. But while that runs, we can go on and continue with our assessment. So now that we have the hashes, you can either choose to store them or just copy and paste them somewhere so that you can use them at a later stage. Okay, so now that this is loaded up, we will just copy the hash here and go paste it there over at CrackStation. So CrackStation is quite good because unlike other tools, you don't have to specify exactly what the format of the hash that you're trying to crack is. It automatically detects it and attempts to crack it. So here says unrecognized hash format. That is fine. We just attempt to crack it one more time, and if we fail, then that means we have to crack it using an offline tool. Okay, so definitely means that we need to crack using an offline too. Okay, since quick session was not part of our scope for the assignment, we are going to skip that. Now, we want to do an LSA dump. So what an LSA dump does is pretty much almost the same with hash dump, but LSA is a active repository over in memory that stores the actual password, not the password hash. So it's pretty useful to use the LSA dump compared to the hash dump because you don't have to crack the password. But on another note is quite not favorable because sometimes you want to get access to the administrator account, but then the administrator account was not logged in the moment that you extracted the VMM. That means if you check the LSA dump, you won't find the actual password there. So it has its pros and cons. So we're just going to repeat almost the same command, or at least most of it, but then we're going to add LSA dump to the end because now we want to do an LSA dump. We no longer want to do a hash dump because we want the actual password. So we do LSA dump, we say enter, we wait as usual. So basically, the LSA dump, what we'll do, it will drop the password in the hex side of the response, which is still fine because especially if there are no spaces within the characters for the password, you just have to just follow them, the passwords, follow the actual words rather, the actual letters rather. Then you could just copy them and paste them. Another small misgiving is sometimes the LSA quite stores these passwords, but they don't necessarily relate to a specific user. So when you're working with a machine with a lot of users, it might be difficult. So here you can see that we have a password here which says Morty is a real author. So we could just copy it from here, then attempt to clean it up, or we could just type it in ourselves and then just pretty much store it somewhere else. So it's really an author. So this is a password that says Moti is really an author. So assuming that we could just safely use an assumption that we have administrator and guest here, it's probably going to be a read password. So we could try to then maybe say when we have access to the machine again, we will try and log in using that username and this password combination. So that's it for the LSA dump part. So there's quite a lot of things that we can do with uh, volatility, I mean, as far as just looking at what was happening goes. So for example, lastly here, let's just try and look at the processes that we're running. So we could use a PS list, which is pretty much the same in PowerShell, where you can just do plist. So we are going to just attempt to do that ourselves as well. So here we go, PS lists. So what this PS list command does is pretty much shows you all the running processes that were running prior to the machine was shut down or just at the point where we managed to get the premium. So there's quite a lot of processes that are running here. You see we have win logon, which always runs, and then has PID 432. We have the LSS. So this LSS process is the same process that we used here when we did LSA dam. So it's constantly running. Why? Because probably sometimes there are some services running on the machine, right? And some applications, and then they need authentication over the Windows user account. So instead of having to convert the NTLM hashes here, they just pretty much favor to use the real time password, the real actual password without the hash to make that authentication. So it almost always makes the same request as the one we made here, but then it does it on its own in an automated process. So there's quite a number of processes open. You see here we have Chrome open. You see we have Notepad, CMDXE, etc. So that's it for our presentation, and then we are going to move on to the next two that we have on the list, which is Nessus. Thank you.